Let's have a look at how we can reconstruct terrain that is hidden underneath a stockpile on a site that has no previous drone data. In complex environments, the volume calculators that are built into many open source and proprietary software platforms won't get the computations right because they are taking too much information from elsewhere into consideration. So let's have a look at how we can clean up this data and reconstruct the terrain beneath the stockpile in order to get accurate volume measurements using open source software. Cool, so here we have the property and here is one of the stockpiles, and as you can see we've worked out the area for the stockpile. We also want to calculate the volume, but if we look closely here we can see that the terrain is quite uneven. So the change in terrain becomes even more obvious when we look at our 3D model here. So we can see here that the terrain is going in a sort of an S shape along this profile. If we look at it from another angle, we can see that the slope of the hill behind these trees is actually going off to this side as well. So we have to build a digital representation of what the ground looked like before the stockpile was put in place. So using the standard volume calculator in QGIS isn't going to work well enough. We're going to have to use additional software like Cloud Compare to actually look at these points. So in order to do that, we need to make sure that when we're drawing our polygon in QGIS that our vertices, or every time we click the button, the vertices are landing on the ground and not in the trees. Because we're going to use this polygon to actually clip the point cloud in Cloud Compare. And that's also what we're going to use to recreate the terrain underneath the stockpile. If our vertices landed up on the trees here, it's going to confuse the algorithm in Cloud Compare and take that vertice and think that that is one of the ground points. So it's not going to render a very good 3D representation of the terrain underneath the stockpile if we do it that way. So let me show you what I mean. So as you can see here we have our stockpile. We've clipped it out of the point cloud in Cloud Compare, and we also have our polygon. And our polygon has the Z-axis information from the digital surface model in it as well. So as you can see very clearly here, it now follows the profile of the ground underneath the stockpile. So if we remove the stockpile, we can see this quite clearly. That's why it's important to have our vertices very close together, but on the ground alone. And from this we can reconstruct the ground underneath the polygon, like that. Now it becomes very easy to calculate the volume of the stockpile as well as the height information from the stockpile as well. So we can see the scalar field actually gives us the heights in meters along the entire profile of the stockpile itself. So here we're looking at about 4 meters, and over here we're looking at about a meter above the ground, and these blue points here are ground points. And here we can see our volume calculations from the 2.5D volume measuring tool, and we're pretty spot on. The best way to do volumes, however, is still going to be comparing one data set to the next. So before breaking ground, it's always a good idea to scan the site first, and then you have a point cloud that you can then compare to your next scan after you've broken ground and started developing the site itself. To learn how to use open source software solutions for all your drone data analysis and processing, go to Geowing Academy today.